Okay, so as promised, I'm going to record a different set of videos to replace the ones that got corrupted, and we are going to basically work our way through the homeworks this week. So the reason I think that's worthwhile doing is basically this week we got a whole bunch of new formulas. So here they all are, all of our new formulas. So notice this is going to let us do things like find the cosine of a sum or a difference. And that's going to remind us of our cofunction identities. So we've seen these cofunction identities before. We looked at them way back in the day. You may remember we built a right triangle and we talked about why these cofunction identities are the way they are. We've got sine of sum and difference. We've got tangent of sum and difference. Not gonna lie, these are very rarely used. We've got double angle identities. These are pretty handy because they let us find twice an angle. We've got product to sum identities and we've got sum to product identities. Okay, so all of these different things that we're going to be using today. And one of the trickiest things I think is to pick which one you're supposed to use on what problem. So I'm going to try and model that this week by going through our My Math Lab homework, and I'm going to be working the even problems. Now, realize that this may not look exactly like your My Math Lab because My Math Lab does randomly generate numbers for different problems, but it should give you a pretty good idea of sort of what we're doing this week and how to work our way through these problems. All right, so let's get started. I'm on number 2. So this is My Math Lab number 19. I'm looking at problem 2. Select the correct choice below that matches the given expression with the identity. Okay, so make that a little bigger. So we're going to come over here to our identities page and notice that we have cosine of x minus y. So this is cosine of a difference. So we're going to be using this little equation right here. Cosine of a minus b equals cosine a cosine b plus sine a sine b. Okay, so notice that this subtraction translates to addition here. So I'm going to pick cosine x, cosine y, sine x, sine y. Woohoo! All right, so let's go ahead to we're actually going to go to number 4. Okay, select the correct choice below that matches the given expression with an expression that forms an identity. Okay, so remember that pi over 2 is the same thing as 90, and anytime we've got those 90s running around, these are our cofunction identities. This really says tangent of 90 minus x equals what? So we can come down here and find our tangent cofunction identity. Okay, so this says tangent of 90 minus theta equals cotangent of theta. Remember that 90 and pi over 2 is the same thing. So this is going to be equal to cotangent of x. That's just what our identity says. All right, moving on. We're going to go to 6. Ooh, find the exact value of the expression below. Cosine of 75. Now, if you're tempted to go to your calculator and type in cosine of 75, 1, make sure your calculator is in degrees and not radians, and 2, don't do that because that's going to give you the wrong answer. Okay, so what this is asking us to do is this is asking us to figure out how we can write 75 as some of those common angles that we're supposed to know the values for. Okay, so what do I mean by that? Well, let me stop my share and pull up my screen real quick. Okay. So the trick with this one is to remember our common angles, or the common angles that we know. So this is things like 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees. Okay, those are the angles in the first quadrant that we know. So then the question becomes, can we write 75 as some combination of those things that we know? 0 degrees, it's kind of useless, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So if we can write 75 as a combination of those, then we can use our cosine sum difference equation to rewrite cosine 75 as things that we know. Well, notice that 75 is equal to 30 plus 45. Okay, so cosine of 75 is the same thing as cosine of 30 degrees plus 45 degrees. Okay, and one of our identities says cosine of a plus b is equal to cosine of a cosine of b minus sine of a sine of b. So we're going to use that identity to rewrite this as cosine of 30 times cosine of 45 minus sine of 30 times sine of 45. So we're just using our identity to rewrite 75 in terms of 30s and 45s. And what's the advantage to that? Well, the advantage to that is we should know what each of these are. Okay, so if you need it, you may want to pull up a unit circle. Okay, so I've got a unit circle over here. So here's our unit circle. And so from our unit circle, we want to know what cosine of 30 is. Cosine of 30 is square root of 3 over 2. And that's going to be times cosine of 45. Cosine of 45 is square root of 2 over 2. minus sine of 30. Sine, excuse me, of 30 is 1/2 times sine of 45, which is square root of 2 over 2. Okay. Now we're just going to combine these things, algebra these things, right? So square root of 3 times square root of 2 is the square root of 3 times 2, or the square root of 6. 2 times 2 is 4, minus 1 times the square root of 2 is the square root of 2, over 2 times 2, which is 4. Notice that this already has a common denominator, so our exact answer is the square root of 6 minus the square root of 2 over 4. Okay, all right. Okay, so let's look at this next one. Next, we are asked to find the cosine of negative 105. Okay, so I'm going to be honest with you. The trick to these problems is trying to figure out which of the angles on our unit circle, so you can see our unit circle here, we can combine to get negative 105. Okay, as long as I can add or subtract any two angles within our unit circle to get that negative 105, then I should be good to go. Okay, all right, so let's see, how could we get negative 105? Well, there is more than one way to do this, but one way is I could do negative 60 and negative 45. Negative 60 plus negative 45 would give me 105. Now looking at our unit circle, right, remember if we're going backwards or we're doing negatives, right, it means I'm working clockwise. I just forgot clockwise versus counterclockwise. Okay, so to start here and go negative 60 would get me right here. Okay, negative 60 would be right here. Okay. And then similarly, to go negative 45, I'd start here and go 45 degrees would get me right here. Okay. Okay, so we're going to think of cosine of negative 105 as cosine of negative 60 minus, I'm just writing this down, minus 45. Okay, I'm going to go ahead and go to the board real quick, and let's see if we can't work this out. Okay. So cosine of negative 105 we're going to think of as cosine of negative 60 minus negative, oops, just minus 45, sorry. Screw that up. Sorry, I kind of screwed that up a little bit when I was talking about it. We're going to fix it now. Okay, everybody feel okay that cosine of negative 105 is equal to cosine of negative 60 minus 45. Negative 60 minus 45 is going to be negative 105. Okay, so that means we're going to use our cosine sum difference equation. That is the subtraction version. So cosine of A minus B equals cosine of A, cosine of B plus sine of A, sine of B. Okay, so what is this going to look like? Well, we'll have cosine of our first term, negative 60, times cosine of 45 plus cosine, oops, come on, cosine, sine, I can read, of negative 60 sine of 45. Okay. So in this case, when we flip back to our equation here in a minute, right, this negative 60 is acting as our A in our equation, and 45 is acting as our B. And our formula says cosine A, cosine B plus sine A, sine B. So all I've done is substitute in. Okay. Now what we need to do is we need to look at our unit circle and figure out what cosine of negative 60 is, cosine of 45, sine of negative 60, and sine of 45. Well, in a minute, I'll pull up our unit circle so we can look at it together, okay? But first, cosine of 45 and sine of 45, those are ones that I feel pretty confident with. Cosine of 45 is the square root of 2 over 2, and sine of 45 is also square root of 2 over 2. So now let's remind ourselves cosine of negative 60 and sine of negative 60. So again, I'm going to share my screen again. Somehow. Okay, so looking at our unit circle here. Okay. So we got our 45s from here. Square root of 2, square root of 2, square root of 2 over 2 over square root of 2 over 2. Negative 60 means I start here and I go backwards 60 degrees, which would get me to here. Okay, so cosine of negative 60 is 1/2. Sine of negative 60 is negative square root of 3 over 2. So I'm going to head back to the board and plug those things in. Okay. So cosine of negative 60 was 1/2. Sine of negative 60 was negative square root of 3 over 2. And now we just need to arithmetic. Okay. 1/2 times square root of 2 over 2 will be square root of 2 over 4 plus negative square root of 3 over 2 times square root of 2 over 2 is going to be negative square root of 6 over 4. Putting these together gives us square root of 2 minus square root of 6 all over 4. So that's going to be our exact answer. Okay, so next question says cotangent of pi over 3 equals blank pi over 6. And we're asked to use the co-function identities to complete the given statement. Okay, so remember that our co-function identities relate our different trig functions together using this 90-degree relationship. And they came from drawing kind of basic triangles and looking at how things are related. Okay, so we did this a long time ago, I remember, because we were actually in class together and it was glorious. Okay, but in this case, we're looking for the co-function of cotangent. So if we look at our co-function identities, notice that tangent and cotangent and tangent are co-functions. So simply by that logic, this almost has to be tangent. However, if we want to check that, and you know we do, okay, one thing we can do is remember this 90-degree relationship, or pi over 2, 90 degrees and pi over 2 are the same thing, between a function and its co-function. Okay, so what do I mean by that? Well, I'm going to come over to the board. So we're trying to show that cotangent of pi over 3 is equal to tangent of pi over 6. Okay. Well, we could do this with a right triangle, but for this particular example, let's just think about this directly through cofunctions. So again, remember that cofunctions have this relationship that if something is equal to its cofunction, the degree measures have to add up to 90 degrees, or in this case, pi over 2. So pi over 3 plus pi over 6 should be equal to 90 degrees, or pi over 2. Let's make sure that that's true. In order to add these together, I need to get a common denominator. The common denominator is going to be 6, so I'm going to multiply top and bottom here by 2. That gives me 2 pi over 6 plus pi over 6. 2 pi over 6 plus pi over 6 is 3 pi over 6. 3 over 6 reduces, so I definitely get pi over 2. Okay? So we've shown that this co-function identity holds true. Okay? So our answer, if I go back to screen sharing, should be the cotangent of pi over 3 equals tangent of pi over 6. All right. So match the given expression with the expression that has exactly the same value. Do not use a calculator. Okay, so sine of 44 degrees. So let's look through our list and see if we can figure out which of these might be exactly the same as sine of 44. All right, so when I look at the first one, cosine of 46. Well, what do we know about sine and cosine? Well, we know that they are cofunctions, right? So sine and cosine are cofunctions, meaning if these two are equal, sine of 44 and cosine of 46, then their arguments, the angle measures, have to add to 90. Well, 44 plus 46 is 90. So by cofunction arguments, these two, sine of 44 and cosine of 46, are the same thing. Let's go through and check and make sure that there's not something else that we're missing. So sine of 44 and sine of 46. Well, it doesn't really make sense for those two to be the same thing. 44 degrees is not the same as 46 degrees. Cosine of 44 and sine of 44. Well, this would actually be true if we had 45, because at 45 degrees, both cosine and sine are equal to the square root of 2 over 2, but it's not true for 44. How about negative sine of 44 degrees? That almost looks like we're trying to do something with our even and odd functions. Those were the identities that we looked up last time, or used last time. So if we pull up this identity sheet, right, notice that sine is an odd function. Odd functions have the property that negative sine of x equals sine of negative x. So negative sine of x, or negative sine of 44, I would expect to be equal to sine of negative 44, not just sine of 44. So it sure seems like cosine of 46 is our best answer here. All right, go us. Okay, so our next question is again looking just at our basic fundamental identities. So we have sine of a plus b. So this is a sum difference of sines. So let's come down and look at sum difference of sines. And we have sine of a plus b. Okay, so sine of a plus b is going to be sine a cosine b, cosine a sine b. So notice that for sines and cosines are plus and minus, so sine a plus b translates to plus and minus here, whereas with cosines, it's opposite, right? Cosine a plus b equals cos a cos b minus cosine a minus b is cos a cos b plus. Okay. The other big difference is that for cosine, notice that our terms go cosine, cosine, sine, sine, cosine, cosine, sine, sine, whereas for sine, right, sine of a plus b is sine, cosine, cosine, sine. Okay. All right, so with that in mind, flipping back over here, the cosine of a plus b is going to be sine a cosine b, cosine a sine b. So this is just asking us to review an identity. Okay. All right, I kind of forgot that I was doing odds and evens. This is an even, so we'll just go ahead and do this one. Okay. So tangent of a plus b, this is one of our tangent sum differences. So moving right on down, this looks like this guy. Okay. So tangent of a plus b is going to be tangent a, tangent b. So tan a, tan plus tan b on top, and then 1 minus tan a, tan b. Okay, so notice that in this case, that is not the first one. It's tricking us because these are minuses inside of there. So we need the one that has a plus on top, tan a plus tan b, and a minus on the bottom. 1 minus tan a, tan b. Okay. Awesome. Okay, so I'm going to go back to doing evens, which is what I was trying to do. Okay, find the expression that is equivalent to this. Oh my goodness. So this will look really intimidating, but think about that question that we just did. This looks like a sum difference of tangents. Okay, so let's see if we can figure it out. It's going to be dependent on sign. So notice that I have a plus on top and a minus on the bottom. So when I come into my two versions here, this one over here has a minus on top and a plus on the bottom. Over here I have a plus on top and a minus on the bottom. So I'm specifically looking at this formula right here. Okay, now what is my A and what is my B in this case? Well, the easiest place to pull that is going to be the top. The top says tangent A plus tangent B. So over here, we have tangent of 3 pi over 5, that's our A, plus tangent of pi over 6, that's our B. So this whole statement is going to be equivalent to tangent of 3 pi over 5, I can read, plus pi over 6. Okay, so let's simplify that. Okay. So we're going to simplify what's on the inside here, 3 pi over 5 plus pi over 6. To do that, we're going to need a common denominator. To get my common denominator, which is 30, I'm going to multiply this guy by 6 over 6. 6 times 3 pi is 18 pi. 6 times 5 is 30. I'm going to multiply this guy by 5 over 5. 5 times 5 is 5 pi. 6 times 5 is 30. So on the denominator, I'll have 30. On top, I'll have 18 pi plus 5 pi, which is 23 pi. So this is going to be equivalent to tangent of 23 pi over 30. Now let's go back and see if that's one of our options. Well, it looks like it's the first one, tangent of 23 pi over 30. So let's check it. Yay, go us. Okay, so last question. Okay, so here we're asked to watch the video and then solve the problem given below. Well, I do really encourage you to watch the videos. I think they're kind of helpful, but I'm not going to make you watch a video within a video. That seems very matrixy. Okay. So we're going to verify that this equation is an identity. So how do we verify identities? Well, we start with the more complicated side, and we try and force it to look like the less complicated side. Okay. Well, in this case, the more complicated side is certainly this left-hand side, and they're even giving us a hint. They say apply some identities to each term in the expression, cosine 5 pi over 6 plus x plus sine pi over 3 plus x. Type the new expression below. Okay, so let's start by looking at this cosine 5 pi over 6 plus x. Well, that's a cosine addition thing. We're going to come back up here to our cosine addition. If I have cosine of a plus b, that's going to be cosine of a, cosine of b minus sine of a, sine of b. So cosine of 5 pi over 6 plus x is going to become cosine of 5 pi over 6 cosine of x minus sine of 5 pi over 6. Oops. Goodness. Sine of x. So all we did was apply this top cosine sum formula to our cosine of 5 pi over 6 plus x. Now we're going to do the same thing for sine of pi over 3 plus x. So we're going to go down and remind ourselves of our sine sum formula. Sine of a plus b is sine of a cosine b plus cosine a sine b. Okay, so sine of pi over 3 is going to become sine of pi over 3 times cosine of x plus cosine, sorry, I can't type, cosine of pi over 3 sine of x. Okay, so we're going to check our answer. Yay, go us. All right, evaluate the trigonometric functions with specified angles, but do not simplify further. Type the new expression below. Okay, so what is this asking us to do? Well, it's saying within this equation here, there are things that we know based on our unit circle, right? So I'm going to pull up our unit circle here. Okay, so in particular, cosine of 5 pi over 6, what's cosine of 5 pi over 6? Well, cosine of 5 pi over 6, we're going to go find 5 pi over 6. Here it is. And remember, it goes cosine sine. So cosine of 5 pi over 6 is negative square root of 3 over 2. Okay, so negative square root of 3 over 2 times cosine of x. So notice that this is specifically saying do not simplify. So my math lab literally wants us to say cosine of 5 pi over 6 is negative square root of 3 all over 2. We can't really do much with cosine of x minus, what's sine of 5 pi over 6? Sine of 5 pi over 6 is 1/2, so minus 1/2 sine of, not 9x, x, plus sine of pi over 3. Here's pi over 3. Sine is square root of 3 over 2. So plus square root of 3 over 2 cosine x plus cosine of pi over 3. Cosine of pi over 3 is 1/2. 1/2 sine x. Okay, so this is literally trying to step us through how we would prove this identity. First, we would expand using our cosine and sine sum formulas. And then we would replace the known values. So we know cosine of 5 pi over 6, we know sine of 5 pi over 6, we know sine of pi over 3, we know cosine of pi over 3. Okay, be careful here because the temptation is to simplify. It says don't simplify, so I'm not going to simplify. Okay, all right. The previous expression equals 0 by which of the following? Okay, well, don't overthink this too much. If you look at this and start simplifying, notice that we have a negative square root of 3 over 2 cosine of x and a positive square root of 3 cosine of x. Don't those just cancel? We have a negative 1/2 sine of x and a positive 1/2 sine of x. Don't those just cancel? So no identity is required. It just simplifies just by good old algebra. Okay. All right. So there's kind of a walkthrough of our My Math Lab number 19 homework, looking at how we can use kind of our top 3 set of equations: cosine of sum and difference, cofunction identities, and sine of sum or difference. All right, hopefully this is helpful for you guys.